Hello everyone. So previously we were done with the greedy based algorithms actually. Yeah. The last one was Baruka's algorithm, I think, for the minimum spanning tree. Yeah. So from today, let's start with the topic actually, or let's start with the algorithm. This one, Sieve of Eratosthenes, right? So this is one of the famous algorithms. So we are starting with the number theory algorithms, right? So now, this is one of the famous algorithms that we need to know at any cost. We'll get the opportunity to implement most of the times this one, especially this algorithm. Yeah. So this is based on the prime numbers actually. Yep. So let's see what the definition part say here. So the sieve of Eratosthenes is an efficient algorithm to find all the prime numbers up to the given limit m, right? So to the given limit n. Yeah. So again, the sieve of Eratosthenes is an efficient algo to find all the prime numbers up to the given limit n, right? So it works by iteratively marking the multiples of each prime number. Yeah, by iteratively marking the multiples of each prime number. Yeah, starting from the 2, the first prime. It will start from the 2 and it works by iteratively marking the multiples of each prime number. Just remember this one. Yep. 2 will be the first prime. Yep. So let's get into the explanation part here. So just listen to this carefully. The same thing will be articulating in the form of code. Yeah. So instead of checking each number for primality one by one, which is actually slow. Yeah. If you keep on checking the individual number for the primality, it will be quite slow, right? So the sieve of Eratosthenes eliminates the multiples of this one multiples of every found prime number. Yep. So we begin with the list of numbers from 2 to n. Yeah. So we begin with a list of numbers 2 to n. So starting number will be 2 and the n number that we give actually. Yeah. Then repeatedly mark all the multiples of this one 2, 3, 5, etc. as not prime. Yep. As not prime. So the numbers left unmarked at the end are the prime numbers. Yeah. The numbers left unmarked at the end are the prime numbers. We'll see this one when we write the algorithm and when we go with the example usage, not to worry. Now, this one I found it very useful as well. The time complexity of this particular algorithm is n double log n, right? N, this one big of n double log n, which makes it highly efficient for the large values of n. Yeah, I hope this part is completely clear, man. Yep. Now, let's try to articulate the same thing in the form of code actually. Let's start writing the algorithm. First, we need to take the input from the user, right? So I'll just go with a n equals int here. So let me give input. So this is fine. Let's write something for the interactive purpose here. Enter the limit here. Enter the limit to find all this one prime this one numbers up to n. Yep. So this is fine, I believe. Next, let's go with the step 2. So what's the step 2 here? We have to create a Boolean list where true means prime. Yeah. True is nothing but it is the prime number. Yep. Initially, we assume all the numbers are prime except 0 and 1. Just remember this. This step is very important. What we are doing here, we're just creating the this one Boolean list where the Boolean value true means it is prime. Yeah. And also initially we assume all the numbers are prime except the numbers 0 and 1. Right. So I'll just write it in this way. Is prime equals initially let's set this one to the Boolean value true into n plus 1. This is fine. Next, let me go with is prime of 0 equals is prime again of 1, 0 and 1. We are considering this one as this one, right? Not prime actually. Only the 0 and 1. We are not considering this one or not prime, right? So I'll just go with Boolean value false. So this is fine. So the next step would be let's hop into the third step, right? Let's move on with the third step here. We have to start making multiples of each prime number. So initially we set the p to 2 and then let me write the while loop here. While p into p equals, sorry, we have to check, right? So less than or equal to n, then what we need to do here, sorry, give this colon here. So if p is still marked as prime, if P is still marked as prime, then we have to mark all the multiples of the P as not prime, right? So I'll just write the simple if condition here. If is prime of P, meaning if P is still marked as prime actually, then we have to mark all the multiples of the P, this one as not prime. So let me write the for loop here for I in range. What's the range here? So this one will be P into P, n plus 1, along with the n plus 1, it will be P. So this is fine. The next part would be, let me go with is prime here. Is prime of I. Let me set this one to the Boolean value false. Let me set this one to the Boolean value false. Right. So finally, what I'll do, P equals P plus 1. P equals P plus 1. Yeah. So now let's move on with the further step. So let's move on with the fourth step or the final step here. We have to collect and print all the prime numbers. So let me consider the variable primes. Let me assign this one to the empty array. And also let me go with the for loop. I'll just go with for I in the range. Range has to be actually from 2 to n plus 1. Yeah, 2 to n basically. For the safer side, we'll be going with 2 to n plus 1 here. If again, let me go with is prime here, right? Is prime of I, then what we need to do, we have to collect and print all the prime numbers, right? So I'll just append I to the primes here. I'll just go with append, what we need to append, I to the primes. So yeah, so this is it for the this one algorithm. Very simple one, man. Yeah, let's print something for the this one interactive purpose. So I'll just go with the primes. Sorry, not primes. Print actually. Prime numbers up to whatever this one up to n we can consider, right? So whatever the number that we give, the user gives the input, whatever the input the user gives, right? Number basically. So R, all we have to do is we have to pass the primes here, right? So I'll just pass the primes. Yep. So this is it for the code actually. Yeah. So this is fine, man. So this is it for the code. We are done with the algorithm. I have explained you this one step by step. We are clear, extremely clear with the this one algorithm part, right? So now let's move on with the input and output part. So here, what is the output that we need to get if we run the code? This one here, if we run this algorithm, first of all, it will ask us to enter the limits to find all the prime numbers up to n. Yeah. Suppose if I give up to 30, right? The simple one, the 30. So the prime numbers up to 30 are basically we have to get 2 is the prime number. 2 is the only this one even prime number as well. 2, 3, 5 is the prime number actually. 7 is the prime number. 11, yeah, 13, then comes 17 actually, 19 as well as 23, and finally 29. Yeah, finally 29. Yep. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 prime numbers between this one within the 30, within the digit 30, right? So we have to get this one as the output basically. When we if we give the this one n equals 30, when we considered n as 30, or when we consider n as 30, yeah, this is fine. Let me delete this one. We have complete understanding of the algo. So let me copy the file name. We come here, give control J. So let's wait for some time. Yeah, Python followed by the file name.py. Yep. So here it's asking here. See, we are giving the input. Enter the limit to find all the prime numbers up to n. So let me give the this one 30 itself, right? So we know. So prime numbers up to 30 are this one 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. You can count the same 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same thing. We are getting absolutely this one absolute desired output, right? Yeah. So we are getting the correct output. Whatever the output that we are getting is absolutely correct. Yep. So we are starting with basically accordingly with the algorithm. What is happening here? Let me explain you. So we are starting with 2 basically. Algorithm starts from the number 2 and until 30, right? So as we have considered here 30 in the input I have given 30, right? I considered 30. So we will mark all the multiples of 2. We'll mark all the multiples of 2. So multiples of 2 are 4, 6, 8, 10. So this one goes on actually 10, 12, 14, 16, 18, 20, 22, 24, 26, 28 until 30 as not prime. So this even number cannot be prime, right? So we will mark or the multiples of 2, 4, 6, 8, 10 up to 30 as not prime actually, sorry, as not prime. So next prime is 3, right? So next prime is 3. So we will mark all the multiples of 3, all the multiples of 3 as non-prime. So in this case, it will be this one, 9, 12, 15, 18. 9, 12, 15, 18. So this is fine up to 30, right? Up to 30. 9, 12, 15, this one as not prime actually. 9, 12, 15, 18, 30. These are not prime, right? So these are basically 12 is divisible, this one. Basically divisible by 3, this one, or 4, even 6 here. This is fine, man. Same goes with the 15, 18 as well as the 30. They are not prime. So the next prime after 3 is 5. Next prime after 3 is 5. So we will mark 25 and 30 as not prime. We'll mark 25 and 30 as not prime, right? So we'll continue this one until square root of 30. We will continue this one until square root of 30. That is nothing but we'll get almost near to 5.4, I believe. Yeah, square root of 30. 5.4, right? So remaining unmarked numbers are the primes basically. Apart from whatever the numbers that we got here from 2, 3, 5. So remaining unmarked numbers are the primes actually. Remaining unmarked numbers in the sense. So here we get 2, 3, 5, 7, 11, 13, this one 17, 19, 23 as well as 29. So these 10 numbers actually, right? So these basically remaining unmarked numbers are the primes, these numbers actually. So this one, the output that we have to get, this one, which is equivalent to the output that we have got actually. Yeah. So whatever the algorithm that we have written works absolutely correct here in this case. Yep. Works absolutely correct here in this case. So this is it for the sieve of Eratosthenes. Very simple one. Yeah. So now, as we are done with the algorithm, let's do one thing. Let me summarize whatever we have learned so far. So there are some this one, 3 to 4 important points that we have to know at any cost, that we shouldn't basically forget. Yeah. So let me summarize whatever we have learned so far. So this one, the algorithm type is basically Sieve of Eratosthenes. The algorithm type is number theory or the prime generation. We can call this one as prime generation. Yeah, number theory or the prime generation, the algorithm type. So what is the time complexity? The time complexity we have already discussed. So this one is big O of n double log n. Yeah, n double log n. So this is the time complexity. So what is the space complexity here? Space complexity is nothing but the big O of n. Yep. So let's discuss the use cases as well. Use cases of the Sieve of Eratosthenes actually. So basically, we are efficiently generating all the prime numbers up to the large limits, right? So this is useful for the cryptography and the competitive coding, right? So this is useful for the cryptography as well as the competitive coding. Many times, if you are giving the contestant the code forces or the code shifts or this one or the it coder as well, so you'll come across this one, the questions. Basically you can implement this one, Sieve of Eratosthenes, right, many times, right? So this is very helpful in the cryptography as well as the competitive coding. Yep. So this is fine. The final one here would be the core idea is to repeatedly eliminate the multiples of the each prime starting from the 2. Then the remaining numbers, the numbers that are left actually are the prime numbers, right? So this is the core idea actually. Yeah. Repeatedly eliminate multiples of each prime numbers starting from the 2. Starting from the 2 goes on. Yep. So these are some of the important points that we need to know, that we have to remember at any cost about the Sieve of Eratosthenes. Yeah. Simple one. Now we are done with the Sieve of Eratosthenes algorithm. So this is it. Next, we'll be discussing on the topic segmented sieve, right? Segmented sieve algorithm. Yep. So for now, this is it. Thanks for watching, guys.